Assume that a simple random sample has been selected and test the given claim. The weights in pounds of discarded plastic from a sample of households is summarized by the statistics. N equals 62, X bar equals 1.911 pounds, and S equals 1.065 pounds. So 62 households were sampled. The sample mean weight of discarded plastics was 1.911 pounds, and the sample standard deviation for weights of discarded plastics was 1.065 pounds. Use a 0.05 significance level to test the claim that the weight of discarded plastic from the population of households is greater than 1.800 pounds. Alright, so here's the claim. This is testing a claim for a population mean. So it's mu equals, and then the alternative hypothesis is either less than, not equal, or greater than. In this case, it's greater than. Mu greater than 1.800, so that's the alternative. The null is mu equals 1.800. Our claim is with the inequality, so it's either sufficient evidence to support or insufficient evidence to support that claim. It all depends on where the test statistic falls. Since we do not know the population standard deviation, which you rarely do, but we don't know it, they don't tell us the population standard deviation, we are going to use the t distribution. So this is t. 0 in the middle. It is a right-tailed claim, so we need t sub alpha. Alpha was 0.05. So alpha 0.05. We also need degrees of freedom when dealing with t. If n is 62, degrees of freedom is 61. Okay, now, if you use your table to find the critical values, so from the table, t sub alpha, you'd have to go down to 61 degrees of freedom. The table doesn't have 61 on it, but it has 60. So you go to whatever the closest but less than. And then we go down to 60 degrees of freedom, and we want area in one tail 0.05. So we get 1.671. So this is acceptable. 1.671 is fine. If we use inverse t, though, we would do inverse t 0.95 comma 61. That would give us the answer as well. So second bars, number 4, area to the left is 0.95, degrees of freedom 61, and we get 1.670. So very close. 1.670. I'm going to use that one. Using 1.671 would have been fine as well too. All right, let's calculate the test statistic. So in this case, it's t sub x bar. It's x bar minus mu over s over the square root of n. So our sample mean, x bar, is 1.911 minus 1.800 over, and the sample standard deviation is 1.065 over the square root of 62. Plug that into a calculator, 0.821. So we t distribution, we go to 3 decimal places. 0.821 is here. So here's our t sub x bar, 0.821. It is in the do not reject null hypothesis region. So we fail to reject the null hypothesis. You don't need the p-value to come up with the conclusion. This is the traditional method. So we fail to reject the null hypothesis. But let's look at the p-value. So if I drew a line directly above 0.821, the p-value is the area to the right of 0.821. You can see that if the p-value is greater than the level of significance, the test statistic is not in the rejection region. So we just need to find out what the p-value is. With t-distribution, it's hard to use the table to find the p-value. You can do it. You can get a range of where the p-value would be between. So we're going to use t-test on the calculator. So if you go to your graphing calculator, you're going to press Stat, go over to Tests, and you're going to choose number 2, t-test. We're not going to use data, we're going to use statistics. If you had data in a table, you could just use the data from the table. So the mean of the null hypothesis is 1.800. The sample mean is 1.911. The sample standard deviation is 1.065. N is the sample size, 62. We want to do a right-tailed test. We are testing the claim that the population mean is more than 1.8, so it's right-tailed. And then we go and calculate it. And all we want off of this, we know everything else, all we want is p equals. So the p-value, p equals 0.2075. Notice it gave you the test statistic value too. So for D, p-value, p equals 0.2075. So that's the easiest way to determine the p-value when you're working in the t-distribution. So 0.2075 is greater than alpha. If p-value is greater than the significance level, you fail to reject the null hypothesis. So C and D do the same thing. C, with actually B and C combined, is what's called the traditional method. So you got to find the critical value or values if it's a two-tailed test, and then you find the test statistic, which is based on your sample mean, and you see where it lies in the t-distribution. And if it's in the rejection region, then you reject the null hypothesis. Otherwise, you do not reject. P-value, you don't even need to graph any of that stuff. You just compare the p-value to the significance level. But you got to know what p-value represents. P-value is the area from the test statistic to the extreme. So if the p-value is greater than the significance level, that means the test statistic is not in the rejection region, so you fail to reject the null hypothesis. Alright, so either way you do it, and most of the time you're asked for both values, so we're doing both. So we fail to reject the null hypothesis. And if we go back to our original information, the claim was with the alternative hypothesis, the claim was with the inequality. We are testing the claim that the weight of discarded plastic from the population of households is greater than 1.800. When we fail to reject the null hypothesis and the claim was with the inequality, we are saying there is insufficient evidence to support the claim. So there is insufficient evidence to support the claim that the weight of discarded plastic from the population of households is greater than 1.800 pounds. Our test statistic would need to fall here in order to support the claim that the weight is actually more than the 1.800. By being here, there's not enough evidence to support the claim that we're more than. This 0 is representative of the 1.800. This is representative of the 1.911. It's not statistically significant enough to support the claim of more than. So again, maybe that confused you there, what I just did, but that's really what we're talking about. We're failing to reject the null hypothesis, so there is insufficient evidence to support the claim that the weight of discarded plastic from the population of households is greater than 1.800 pounds.